Hello everyone. Today we'll be going through chapters 2.2, types of roots of quadratic equations. So we know, right, from the previous subtopic that the general form of the quadratic equation is ax squared plus bx plus c equals to 0. And from this general form, we can actually find the discriminant. The discriminant is defined as b squared minus 4ac. Depending on the values of the discriminant, whether it's a positive value, whether it's a negative value, or whether it's equal to 0, will determine the types of roots we get. Okay, so for example, if my discriminant b squared minus 4ac were greater than 0, the types of roots we'll get if the discriminants of the quadratic equation were a positive value would be two different real roots. Right? If it were less than 0, then there will be no real roots. If it were equal to 0, then we would have two equal roots. Okay, so let's do a few examples together and we'll illustrate this. All right, so the first example, so let's look at this quadratic equation. X squared plus 3x minus 5 equals to 0. Okay, let's find the discriminant. Let me use capital D, right? So that I don't need to write down discriminant, the whole word every time, right? I calculate discriminant. So capital D to represent the discriminant. So the discriminant is just b squared minus 4ac. So b is 3, so 3 squared minus 4 multiplied by a, which is 1, and c is negative 5. So I will have 9 plus 20, which is 29. So this is greater than 0. Therefore, from this, right, from the value of the discriminant, which is a positive value, I can deduce that this quadratic equation has two different real roots. Let's try another example. Let's say we have this quadratic equation. 4x squared minus 4x plus 1 equal to 0. So the discriminant would be b squared minus 4ac. So b is negative 4 squared minus 4ac. So we will get 16 minus 16, which is equal to 0. Therefore, I can deduce that this quadratic equation has two equal roots. Okay, let's look at last example. We have, let's say, x squared plus 2x plus 6 equal to 0. So if I calculate the discriminant, it will be 2 squared minus 4. A is 1 and c is 6. So this will be 4 minus 24, which is equal to negative 20, which is less than 0. Therefore, I can deduce that this quadratic equation has no real roots. Okay. Finally, let's use what we have just learned to solve a question. Okay. So this question states, the quadratic equation, okay, so this quadratic equation, 1 plus 2q x squared minus 4qx plus 2q minus 4 equals to 0. This quadratic equation has two equal roots. Right, find the value of q. So we know that if a quadratic equation has two equal roots, the discriminant must be equal to 0. That means b squared minus 4ac must be equal to 0. So b from this quadratic equation with a few unknowns would be negative 4q, right, squared, minus 4a would be 1 plus 2q, and c would be 2q minus 4. This is equal to 0. So negative 4q, square that, it's 16q squared minus 4, right? Let's open up the brackets, multiply whatever inside. Okay, so we'll get that equal to 0. So 16q squared minus 4. So we have 4q squared minus 6q minus 4 equals to 0. We have 16q squared minus 16q squared plus 24q plus 16 equals to 0. So this cancels out, 16q squared minus 16q squared. We're left with 24q plus 16 equals to 0. Therefore, 24q is equal to negative 16 and q is equal to negative 16 divided by 24. Simplify the fraction, we'll get 2 over 3. So negative 2 over 3 is the value we have found for q.